below objective and evolution of mx. And let us solve the first question. Their weighting function uh, is a weighting function of f of x, and the weighting function is f of x, which is x by x max to the power alpha for x less than max 1, otherwise with x max equal to 100, alpha 0.7 by computing f of 5 0.0505 and over 0 point gives the 0.31057. So 150 would result in 0.59, which 46, and f40 would result 1 because it used, otherwise f20 f200 would be equals to 1, because since x is greater than the snatching shape behind the curve starts f0 uh, and rises completely glowing quickly, small counts but dismissing marginal increasing following powerless shades x to the 0.75 until it reaches x max at 100, where it flattens completely and stays constantly at 1. For example, x greater than equal to 100. Let's move to the second question. In the second question, word for the pair xi and would 50 transpose j is equal to 1.2 and bi 0.3 and bj is equal to 0.4. The predicted value of b transposes bi plus bj plus bi, which equals to the 1.7j. Actually value is log xi, which is equal to the 0.9120. The squared error would be result in 4.8930. Using the weighting factor for 50 for A and 50 for part A and 0.5946. The weighting squared error becomes 0.544 into 4.930, which results to 0.9. Let's move to the third question. In the third question, deriving V transpose Bj plus Vi plus Bj log Xij, the started Vi transpose Vz approximately equal to the log P given. Log Pj I and Pjp of j given Ix Ij Ixi, which Ixij over the sum. Over Kixik gets B transpose Bj approximately equals to the log Xi minus log and x range change in the terms would be giving vi transpose vj plus of x equals to the xij. Now since xij depends only on row word and gl, so here additional speak symmetric formulations. This term is constantly split and folded into two separate by stems. One observing information specific to word, another one observing information specific to word J. This means log xi maps bi observing word specific offset, and symmetrically xi maps to building the final symmetric from bi transpose bj plus bj log xyz. The bias terms, the bias from times bi and vz can observe locum terms because they free lineable scalar parameters, since the original relation is not symmetric on its own, so restores the symmetric by letting bias land this word. Specific marginal frequency effects leaving the dot product captures only the true symmetric relationship by the words. Let's move on to the fourth question. In the fourth question, uh, the Spearman rank correlation for 5 word pairs. The rank both the human scores, model scores, and from equal to the lowest 5 equal to highest. For cat, dog, human ranks 3. Similarity based on the above and tables and given tables who rank the following. So the sum squares is equal to 2. By applying Spearman formula, we get row 0.90. So here in this, the model acceptable because a spine correlation 0.9 indicates a strong agreement between model ranking and human judgmental, although some similarity values differ. The overall ranking is highly consistent, and this is expected because per man's row measures rank agreement, not the accuracy of actual similarity measures. For the part, we have given analogy that is both equal sister than the what does. Grandson equals to calculate the have computed T formula, and b sister minus v brother and plus v grand. So we have calculated overall formula get t and equals to 0.20, 0.90 and 0.80. Cosine similarity. In the cosine similarity, in the cosine similarity, granddaughter nephew and the uncle, we get granddaughter 0.9986 and nephew 0.4646. Uncle we get 0.2819. The nearest neighbor granddaughter because it is value 0.99816, the higher remaining. As the model correctly identifies the granddaughter as the closest, would showing the successful capture of gender relationships.